We're now going to talk about numerical analysis, which is the technique that physicists and everybody else uses to solve problems that are too complicated for a nice mathematical solution. And that's most problems. Almost any real-world problem is too complicated for a nice mathematical solution. Until recently we didn't have computers, so you had to make do with the nice mathematical solution even though it wasn't very accurate, because you had to make lots of approximations to make it work. But now we have fast computers and we can actually address really complicated situations, real-world situations, using this technique. Numerical analysis was invented in about the 1820s or 1830s to try and study the orbits of planets. If you just have a planet orbiting around a sun, then you can calculate the orbit using beautiful mathematics. But as soon as you mess it up by having, say, two planets which influence each other, then you need a numerical analysis. Back then it was done by people, doing each step of the calculation by hand. As we went on to the 20th century, people started using this technique to calculate trajectories of artillery shells with drag, once again a problem that you can't solve just by mathematics. When the very first computers were invented, they were used often for this process, for example, to calculate atomic bomb yields, and now it's used for everything, whether it's engineers calculating stresses and strains in buildings, or modelling the wind flow around an aircraft wing, to an astrophysicist calculating the origins of the universe. Now, how do you solve something numerically? Well, the first step, just like for everything else in physics, is model. You've got to come up with your model. What is the physics? So before you start doing any programming or any equations, think about the physics. This will typically involve calculating limiting cases. I'll explain that in a later video. It will often involve doing a ninja estimate. And it will usually involve sketch graphs. Now, people are often tempted to skip over this and get straight onto the programming, but that's almost always a mistake. It's worth spending a bit of time making sure you think through all the issues here before you start getting onto the more complicated programming. A bit of time spent on this usually pays itself back 100 times over when you get to the more detailed stage. Once you're pretty sure you understand your model, then you can do the numerical calculation. What we do here is we break one big complicated problem down into lots of small simple problems. And then use a computer to solve vast numbers of these small simple solutions and put them together to make the big answer. So it's all about breaking things down into small bits and then using the power of computers, which are very good at doing small calculations over and over again really fast, to come up with a final answer. Now, sometimes, just sometimes, you can solve these problems using calculus, usually only if they're very simple, and we'll show that where appropriate, but most of the time numerical is the only way to solve these things.